Hi, today we're solving a symmetric tree problem in C++. So the question goes, given the root of a binary tree, check whether it's a mirror of itself, i.e. symmetric around its center, as shown below. If you have a root at 1 and left 2, right 2. And just goes on and on. If it matches this, then it's true. Otherwise, if it's only one side, like this one only has the right side, there's no left side, then it returns false. There are basically two kinds of ways that you can solve this problem. One is the recursive one, where you go use a helper function to go recursively to left or right side. While the iterative way is to try to put it into like a stack or a queue in this case, using a data structure. We're gonna try to solve this in a recursive way first. If you want to check out the iterative way using a queue, you can check out my other video. So without further ado, let's get started. So I've drawn this branch here. There are some edge cases that we can talk beforehand. So what you want is recursively, let's say starting from the root point and to its left, and you want to check if this left is equals to 2. This is the measurement, like the left equals right. If it does not equal, then return false immediately. And there might happen to a case where you only have, like, let's say left branch, there's no right branch, then that's also, of course, you need to return a false. So the other one would be you have a left but you don't have a right, or the other way around, that you only have right or you don't have left. So that's also an edge case where you return. And the stopping case would be, so we get to this 3 and there is no more left and right. We also went through the symmetric side of the 3, and there's no more branches downwards. So like no children below it, then we can return, which means like both left and right are empty, null. So let's start to code this up. First, we're gonna include the input and output, and then include well, we only need to include that one here. Use namespace standard struct the tree node. So the node itself is gonna have a value, like on each node there's a value which is an integer. Let's call it val, and then the left node is gonna be a pointer, tree node left. Similar thing with the right side. And we want to construct the scenarios where there's no parameters, arguments. Like this one, you don't have any branches, so it's gonna be empty inside. In that case, the default value would be 0, and the left side is just gonna be null, similar to the right side. And in a case where it has one argument, let's say x, then the value equals to left, but then the left will be null, so that when we write this node, then we don't have to include left and right because they're defaulted to be null. And the last case would be there's 3 arguments left, the value, the left, which is gonna be a node, the right, does the asterisk goes before or after? I think it goes after it. In this case, the val would be x, and the left would be the left, and right would just be the right. So I think that's about it for the construct. So our class of solution, make it public. It's gonna return a boolean, either true or false. And let's call this function recur, where it's gonna need left. Sorry. Yeah, I think this goes to left. Okay, you declare the type in the front, and then it's gonna be a left pointer, so, and then a right pointer. Yeah, back to our function, you have a left and right node. And first, let's put in the edge cases where your left and right could be null, which means there's nothing in it. So if, well, you can write like left equals to null, and I think you can also write like the exclamation mark in the front, which should be the same. If this is the case, we actually return, like there's no more branches, we need to return true because that's symmetric in a sense. And otherwise, if there is a left but there is no right, okay, let me put this a little bit like organized. if that's the case, or the other way around too, then return false. And the last case would be there are values on both sides, but the values do not equal to each other. So in this case, we return false. Otherwise, if we're done evaluating this too, if it doesn't meet any of these conditions, then this is symmetric, and then we go further down. So the way we evaluate is we want to make sure the left to the left should be equal to the right to the right. And similar thing with this 4. So the right of this left node should be equal to the right of this right node. So this is how you can make sure it's symmetric. So basically you're evaluating these two values here. So we want to return recursively the left to the left and right to the right. If this makes sense. And we need the right, the left, this is the right to its of its left, and the right to its right. Left to its right. Okay, you get the point. Like this 4 is the right node of this 2, which is the left node, and this 4 is a left node of this 2, which is a right node. So left, right, and right to the left. So this should be our recursive function, and now all we need is to call that function. So we name it is symmetric, and we'll need to pass in the root. And all you need to do here is to return recur and then put the root inside. So there's starting from the root, you put the root as the left, and then the root the other side, the root is the right. So it starts to evaluate from compare 1 and 1. Of course this is symmetric, and then it goes to the left, it goes to the right, and measure if left equals to right, or test if they exist first, and then if the value equals, and then keep going downwards and outwards. So let's print out the value, which is our main function. First we need to construct the instances where you have 3 nodes. Let's start from this 3 values, so the third value, the second one, and the first one. So let's call it pointer value 3. It's gonna be equal to the node. The value here is 2, and we can just evaluate this 3 first. So there's no, well, it's like null here, so we don't have to put in there. And then the second value, which is this one, is also the number 2, and the root have the value 1, and to its left it has the pointer value of 2, and to its right pointer value of 3. Now the instance of the class would be the solution. It's called so, and the result, a boolean value result equals to, it's so, and we want to use this function and put the root value in there, and then just console output result. Oh, by the way, actually, I think it's better to delete it first than construct it. So because we want to make it as pointers, and we want to delete the memories from here, so we construct this as a new pointer, or well, 3 new pointers, and then delete them in the end to free the memory. So I think that's about it, unless there's some syntax errors. So let's test this in the console. So G++, the name, I think I named it draft Q C++, and we can output, well, whatever name we want. And yes, it's complaining about I guess because of the semicolon. Recur declared here. Or I should put it like a pair of parentheses around this. Is there any other errors? Recur. Let's see. Too few arguments to function call, expected to have 1. Oh, sorry. Okay. The arguments, yeah. I need to learn the error message more carefully. So there's like left and right 2 arguments here. I mean to put comma here, so to evaluate this one and this one. So this one and this one. Hope that's the problem. Okay, cool. So it returns 1, which means it's true. But let's put like another number. Let's say it's not 2 on the third position, in the third position, but like 3. So 1, 2, 3. So we're expecting it should be a false. It's not symmetric. So run this again and execute 0. Yes, that's the false value. So just a quick recap. the way we solve this problem is using the recursive function, where the left and right are being evaluated recursively, starting from the root. And the edge cases, or the base cases you would call it, is if both left and right are null, like over here, there's nothing beneath it, so we return true, because it's symmetric. Or if there's one side missing, let's say there's a 5 here, but there's nothing on the right side, then obviously that's not true, then return false. The third one would be if there is a 5, but on the right side the value is 6, then this does not equal to each other, then we'll return false. Otherwise, if the values are all equal, then we keep going. If it's the left side, then the left keep going to the left, and the right keep going to the right. These two need to be equal or going through the evaluation there. And from not just the left side to the right side, you want to evaluate this one with on the opposite side of the left side of this right note. So right up, the left, so the left side of the right side. So keep going until we meet one of these conditions. Remember the initialization, we just call this function, and the maintenance, we keep recursively calling this one, and these are the stopping conditions. So I hope this is helpful, and I will link the code below in my GitHub repository. If you're interested, you can go check it out. And thanks for watching, and I hope seeing you